Hi everyone, my name is Ahmed, and this is a presentation I gave to a local Ruby meetup, designing and building RESTful JSON APIs. Wow, that's a lot of acronyms in one slide, but we'll go through it. So the presentation is broken into three parts. First, I'll talk about APIs, what's an API, and why build one. Then I'll talk about, how do you design and build an API, using Ruby on Rails as an example. But you can build it in any way you want. And I'll end with just some things to consider when taking an API and making it a real thing, putting it live. The app, the sample app that I want to produce is called Easy Contacts. It's a simple contact list. You have a name, email address, and Twitter handle for a bunch of people. I'm showing you the user interface just so that you have a visual, because APIs are code really hard to wrap your head around. Also because user interfaces are important. We spend a lot of time designing user interfaces, and just like we spend a lot of time designing user interfaces, we should be just as careful when designing APIs. So what is an API? An API is an application programming interface. It's an interface between the outside and inside, where the outside interacts with the inside using code. It's a really generic concept. So the inside could be, let's say, a server, or it could be a device. Your iPhone has an API so that people can interact with the camera on it. Software libraries, jQuery, Ruby on Rails, they have APIs so you can interact with different parts of them. But this talk is really about web APIs. You've got clients on the outside interacting with the server on the inside, and they're interacting over HTTP, so the web. So why build an API? To me, the advantage of building an API is that you can have multiple clients. You can have, for example, a third-party app, something that runs on a different server that interacts with your API. The advantage here is that someone can build a feature on top of your API, on top of your app, without you, needing to do that yourself. You can separate out your front end into an app by itself, like AngularJS, Ember. They're popular front-end frameworks for building UIs. You can build a native mobile app if that native experience matters to your app. You can build desktop apps. If it makes sense, you can even build a Chrome extension for your app. So hopefully it's clear that building an API gives you a lot of flexibility. So when designing an API, we need to understand, well, who's the customer? Who are we designing for? The person we're designing for is the programmer, the person who's going to write code to interact with our app. The goal is to have a happy and productive programmer. Because this programmer could be you if you're building a front-end UI for your app. It could be a teammate, or it could be someone who's building on top of your platform. You want the experience to be good. You want the people to be happy and productive. So how do we get API happiness? To begin with, I want to talk about REST. So we need a shared solution. We need something that's not new, that's something that other people have used. We don't want to create our own interface that people would have to learn. We need something that's uniform, something that's consistent, something that's predictable. REST it's a convention. It's called representational state transfer. It's a convention for how to really build on the web. It's basically what it is you've got your client-server architecture. This is the basis of the web, and REST puts some constraints on top of that. So what it says is that the server should be, a bunch of resources. Resources could be anything, data. They could be servers that you're interacting with. The resources could be files, photos, images, movies, etc. And what the client does is it asks for a resource and gets representation of that resource. So to give you an example, for our Easy Contacts app, the resource is really contact data, and it's in a database. When a client interacts with their API, what it gets in return is a representation of that data in JSON format. We'll talk about JSON later, but just note that you have resources on the server, the client asks for a resource, and you get a representation of that resource. So how does the client find the resource? How does the client make that request? To do that, the client just needs a URL, we're all familiar with that, a Uniform Resource Locator. It consists of three things: HTTP, so that's the protocol, a host name, which means the server where this resource is, and a URI, which is a unique resource identifier, uniform resource identifier. And basically, the uniform resource identifier is a noun that represents the resource. We use nouns, and that's just the convention. For each resource, you have two URIs. One represents the collection, so the list, in this case, of contacts. One represents an item, so contact slash and then an ID, 2, 3, 4, whatever, represents a single item in that collection. So let's build our API. We're going to use the gem called Rails API. It's just Rails, except there's a few things taken out because you don't need them if all you need is an API. So our API needs to respond to the URI, Uniform Resource Identifier, and it needs to respond to HTTP verbs. And the HTTP verbs tell us, what the client wants to do with that resource. In our routes, what we would do is we would combine an HTTP verb with a URI. So for get means read. The first line means I want to read the collection of contacts. The second line is saying I want to read a single item of the collection, and it's the item with ID something, 25, 26, whatever. So the client wants to just get a representation of that resource. Post means I want to create an item and add it to the collection. Put means I want to update. I want to update a certain item in the collection. Delete, same as update, except I want to delete a specific item in the collection. So as simple as that, with just a few lines of code, we have a router. We have something that will respond to these RESTful requests. Now, what the server needs to do is respond with a status code and a data format. The popular data format is JSON. It looks like this. And it looks, it's called, it stands for JavaScript Object Notation. It looks a lot like JavaScript objects. It's just a data format. It's become the predominant and popular format, so I recommend using it. All we need to do is add one line, and now our API automatically responds with JSON. That namespace API thing there, it just adds the word API in front of the unique resource identifier. So our API is going to be accessed at /API/ say contacts. So we go from routes to a controller so that we can respond differently to each request. So the first request that comes in, get contact, will be handled by a controller called contacts and the action called index, and the same thing for the rest. So in our controller, what we need to do is respond with JSON data. The way we format that data matters. There's a standard out there for how to format JSON APIs. You can see it at json-api.org. And there's a gem that you can use that will automatically implement this for you. It also comes with configuration so that you can tweak it. But using this gem, you'll get the proper format of JSON. So next, what's a status code? We know what JSON is, and we can respond with the right format. How about the status code? The status code is just, it's part of the HTTP spec, and it's just a way to uniformly tell the client what's going on. It's best to actually show it through example. So these are the status codes, but I'll show examples. In our controller, let's say the index action, when we get a GET request for the collection, we respond with render JSON and then send the contacts to the client. But we also give them a status code, status OK, or 200. And that means that you've made a GET request and it's been successfully processed. The show action is for the GET of a single item. We render that item. Here we don't have to say status OK because Rails will do that automatically for us. If someone asks to destroy an item, then we respond with head no content or status code 204. And that just means you ask for something to be destroyed, it's done, everything is good. Update, same thing. If we update it successfully, we don't need to send back anything other than the header saying no content, which is equivalent to 204, which means everything went okay. On the other hand, if something happened, we couldn't update the resource, there's an error, usually validation error, we send back the status code 422, unprocessable entity. And along with that, we send errors. So as you see here, there is in Rails a way to, if a save fails, to get those errors. Why did it fail? And we just send that as JSON back to the client. With create, if we create successfully, we send the status code 201, successfully created. And if we couldn't save it, we couldn't create this resource. Again, we do the 422, unprocessable entity, and send back some errors. The errors need to be verbose. In Rails, this is easy to do because if you, again, as I said, if something can't be saved, you'll know why, and you can just send that back to the client. But what if the person making the request hasn't included their authentication key? They didn't put in their username and password or their API key. Well, 401 is what you would respond with. And it's a good idea to give them more information, like API key not found. Please go here to get your API key. This makes developers happy because now they've gotten the instructions for fixing this. So really, with this, we have an API. We have an API that can be easily consumed on on any client. So if you want to build a front-end UI, you can use libraries like ngResource for AngularJS or EmberData for EmberJS. And they will interact with that API very easily because it's a uniform API. It follows conventions. If you want to build, or someone else wants to build something on the back end, they can use gems like Active Resource, REST Client, and interact with that API. Really, what we have now is a simple API, but it's an API that responds to a bunch of requests and responds with JSON and responds using status code, so everything's working fine. But there might be a few things that you need. So it's a good idea to make the API a bit more flexible. And the way to do that is to take the complexity and sweep it under the query string. So to give you an example, if you put a question mark in the URL, you can include key value pairs, and that information will go to basically the server. So if you're trying to do something like filtering, well, you can do that. You can add, for example, here relationship equals friend, and now instead of getting all of the contacts, what you're getting is the contacts that have a relationship that equals to friend. Of course, on the server side, you would have to implement this. In the example code that I'll share with you at the end, I have implemented this, so you can see how it's been implemented. You can do sorting like this, where if someone sends in order equals something, then you can order the collection like that. You can also do search. Here I'm saying, search for someone with the name Ahmed. Pagination, it's a good idea not to send all of the collections over. If someone asks for contacts, you might have 1,000 contacts. That's going to be a lot of contacts to both get from the database and then send over. So it's a good idea to use pagination. There's a good gem for that called Caminari. Another gem is Will Paginate. And you can implement this relatively easily. You can look at my implementation as well. And finally, for this section, side loading. If you have associations, if you have resources that are associated with other resources, like in this case, for each contact there might be some notes associated with that contact. Instead of asking the client to make each request separately, you can combine them. One way of doing that is to have includes, for example. If someone puts that in the URL and makes a GET request, then make your server respond to that and embed or sideload those resources along with it. And for the last section of this presentation, I just want to talk about a few miscellaneous things, some things that you should consider. This is a small presentation. It obviously doesn't cover everything, so there's a bit more stuff that you need to look at separately. So you might build an API where you need people to access a non-resource, something like calculate or translate or convert, some action that really can't be a noun. So you can use verbs as long as you document it. The problem is that it's not RESTful. It doesn't follow that convention. People will have to look through your documentation to figure out that you do have this this functionality. Another way of doing it is by, in a sense, faking it. You can convert that verb into a noun, like calculate to calculations, and make it a post request. So I want to create a calculation in that resource. The problem is that, of course, people can't get the calculations unless you're storing all of them. So it can get a bit confusing. So this is controversial. A lot of people have different opinions about it. Just do what makes sense for your app. For security, use HTTPS. It just makes sense in production to, with one line of code, force HTTPS. When you're building an API, you're going to make changes that will break the API. And if you do that, you will make people unhappy. And so the best way to deal with this is through versioning. So as you see here, I've namespaced the route under v1, which means this is version 1 of the API. If I ever make a change that breaks the API, I will bump it up to version 2 and basically support 2 versions of the API. So support 1 version back, and that gives people some time to change their client-side code so that the project doesn't automatically break. All that does is just adds the v1 in the URL. So now people would do get/API/v1/contacts. And if they want to access the version 2 of the API, they would do get/API/version2/contacts. And this makes everyone happy. In HTTP, there's a thing called conditional get, which means, let's say a client makes a request for a list of contacts, gets that list. Well, the next time they do it, if that list of contacts hasn't changed, they shouldn't, they shouldn't need to get a list again. They should just go back to the browser cache or whatever caching mechanism and just get it from there. So one way of doing that is to set some headers, set the last modified, when was this resource last modified, and set something called an e-tag, which is just a string that identifies this version of a resource. Rails will, if you use a helper, will automatically do that for you. And what will happen is when the first GET request is made, these headers are set, and then the next time the same GET request is made, the e-tag and last modified will be checked against the current, last modified and e-tag. If nothing has changed, that means, we have no new information for you. Just send back the status code 304 not modified. So in the controller, all you have to do is add this if stale blah blah blah. It's just a helper that does this properly. So this is a good reason to use Rails. gzip compression, it's just a way to reduce bandwidth, and it's relatively easy to implement. Browsers have this problem called the same origin policy problem, which means that if someone is trying to make an AJAX request or a JavaScript request from a browser to your server, the two need to be under the same domain name. And that can be a problem if, let's say, your front-end app is on a different domain name, or you want someone else to build a browser-based app on top of your platform. So there's a gem that will fix this, and it's relatively easy to implement. Again, this is a huge topic, so if you want to know more about it, you should research it. Authentication, obviously. People, it might not make sense for everyone to just access your the data. So you can use basic authentication. There's a lot of APIs that do that. All people need to do is send over their username and password, just like they would log in on a normal app. But they would have to do it on each request. That can be a bit problematic because now you've got usernames and password in code. So API keys or token-based authentication is another good way of doing it. And that way you can just reset the key. If something bad happens, you lose the API key. If someone gets access to it, you can just reset it instead of having to change your username and password. So token-based authentication is sort of a nice middle ground. The more complicated, more robust solution is something called OAuth. It's a huge topic, but the way it's explained, it's like a valet key. You give access to your data using a key. So a user could give access to multiple clients, can give different permissions to each client, and can revoke those permissions whenever they want. So if you've ever used GitHub and another app asks you to connect through GitHub, you'll see that they will ask you to give them some permissions so they can access your repositories and do things with it. Documentation, it's important. I really like this service called Apiary. They've open sourced this tool called API Blueprint. It's a really great way of building API documentation easily. You can also use a gem called RSpec API documentation. What that will do is it will take your RSpec tests and turn them into documentation. Either way, however you go, documentation is key. And if you use Apiary, I highly recommend it. The documentation is just beautiful. There's example code. You can make requests through the documentation, and it's a great service. Finally, testing your APIs. When you're playing around with it and testing it, you can do it through the command line, through a tool called curl. If you're trying to test it through the browser, there's a nice Chrome extension called Postman, which helps you make get, post, delete requests, etc. JSON Formatter is a great plugin or Chrome extension, and basically, whenever you get a JSON response in Chrome, it will format it nicely, and it just looks beautiful. If you're not if, you should test your API. You can either use RSpec, there's a request spec specifically for that, or you can use the mini test that comes with Rails, those integration tests. Those are really helpful. So thank you. My name's Ahmed. Yeah, you can reach me on Twitter if you have questions anytime. This is the link to the code. I have a simple API built, the Easy Contacts. Hope you like it. If you have any questions, please just reach out and I would love to help you. Thank you.